Imagine you are on a very, very long road trip. Now imagine that road trip is in space. You're floating hundreds of kilometers above Earth. You need to breathe, right? You also need fuel to get where you're going, and maybe to get back home. For astronauts, this is a huge challenge. Every single breath of air and every drop of fuel has to be packed up on a rocket and blasted into space from Earth. This is incredibly expensive and limits how far we can travel and how long we can stay. It's like having to pack all the air and gasoline you'll ever need for your entire trip before you even leave the driveway. To solve this cosmic problem, scientists are working on ways for astronauts to make what they need right where they are. This idea is called in situ resource utilization, or ISRU for short. It's a fancy way of saying living off the land. In space, the land is the spacecraft itself, or maybe one day the moon or Mars. The goal is to become less dependent on expensive resupply missions from home. If we can recycle the air we breathe and create our own fuel, we can plan for much longer and more ambitious missions. It's the ultimate form of cosmic recycling, and it's essential for humanity's future beyond our home planet. Just recently, in late November 2025, astronauts aboard China's Tiangong space station took a giant leap toward this goal. The crew of the Shenzhou 19 mission conducted a groundbreaking experiment. They successfully used a new system to create both breathable oxygen and rocket fuel, all from waste products. This wasn't magic, it was science. They used a process that mimics what plants do here on Earth every single day. This achievement marks a major milestone, turning the dream of a self-sustaining space habitat into a tangible reality. It's a critical step toward a future where we can truly live and work in space. This breakthrough is part of a bigger picture. All around the world, space agencies are trying to figure out how to manufacture things in space. For example, the European Space Agency has successfully 3D printed metal parts on the International Space Station. China's new system for making air and fuel is another piece of this puzzle. It's all about building a sustainable ecosystem in orbit. Think of it like setting up a workshop and a gas station in space. These technologies will form the backbone of future exploration, allowing us to build bases, support longer missions, and push the boundaries of human presence in the cosmos. Consider the science. So, how did the Tiangong astronauts do it? They used a process called artificial photosynthesis. Let's break that down. Photosynthesis is what plants do. They take in carbon dioxide, the stuff we breathe out, water, and energy from sunlight, and they turn it into oxygen, the stuff we breathe in, and sugary food for themselves. Artificial photosynthesis copies this amazing natural process, but it uses technology instead of leaves. Scientists have been working on this for years, and now it has been proven to work in the unique environment of space, where there is no up or down. It's a brilliant way to turn waste into treasure. The Chinese astronauts used a special compact device about the size of a drawer. Inside this device is a semiconductor catalyst. A catalyst is something that makes a chemical reaction happen faster without being used up itself. The astronauts fed carbon dioxide, which they exhale naturally, and water into the system. The catalyst then went to work, powered by electricity. It split the water molecules and rearranged the carbon dioxide molecules. The result: fresh, breathable oxygen and a hydrocarbon called ethylene. This is an amazing two-for-one deal in space. One of the coolest things about this technology is that it works at room temperature and normal atmospheric pressure. This is a huge deal because it saves a ton of energy. Many chemical processes require very high temperatures or pressures to work, which consumes a lot of power. Power is a precious resource on a space station, where it's mostly generated by solar panels. By operating so efficiently, this new system doesn't put a major strain on the station's power grid. This efficiency is key to making the technology practical for long-term use in space, where every watt of power counts. Another major challenge the experiment overcame was managing gases and liquids in microgravity. Here on Earth, gravity helps separate things. Bubbles rise and liquids settle. In space, everything just floats around. The Chinese scientists had to design their system to precisely control the flow of gases and liquids to make sure the chemical reaction could happen correctly. Their success proves that complex manufacturing processes are possible in orbit. This opens the door not just for making air and fuel, but potentially for producing other useful materials, like sugars or plastics, far from Earth. To really appreciate how big of a deal this is, let's compare it to the system used on the International Space Station. The ISS has been our home in orbit for over 2 decades, and it has a life support system that has kept astronauts alive all that time. For oxygen, the ISS primarily uses a process called electrolysis. This system uses electricity to split water into hydrogen and oxygen. It works, and it's been very reliable, but it has a big downside. It uses a tremendous amount of energy. In fact, oxygen generation can consume up to 1/3 of the entire space station's power budget. The electrolysis system on the ISS also only solves half the problem. It makes oxygen, but it doesn't do anything with the carbon dioxide that astronauts exhale. That carbon dioxide has to be scrubbed from the air and vented into space. So you're constantly losing carbon atoms that could be useful. The new Chinese system, on the other hand, is a closed loop. It takes that waste carbon dioxide and recycles it into something valuable. It produces both oxygen to breathe and ethylene, which can be processed into rocket propellant. This is a much more efficient and sustainable approach to life support. The versatility of the new technology is also a game changer. By simply changing the catalyst inside the device, scientists can tweak the output. Instead of ethylene, they could configure it to produce methane, another excellent rocket fuel. Or they could make formic acid, which can be a precursor for creating other organic compounds, maybe even sugars for food. This flexibility means the same basic hardware could be adapted for different needs on different missions. It's like having a chemical multi-tool in space, ready to produce whatever you need most. This shift represents a fundamental change in how we think about space missions. Instead of packing everything we need, we're moving toward a model of self-sufficiency. It's not just about oxygen, it's about a whole ecosystem of in-space manufacturing. This breakthrough complements other technologies China is developing, like a satellite launched in January 2025 to test in-orbit refueling. Together, these pieces suggest a future where the Tiangong space station could act as an orbital pit stop, producing and transferring fuel to other satellites or spacecraft, extending their operational lives and capabilities. This incredible achievement in artificial photosynthesis isn't just about making life on a space station easier. It's a critical enabling technology for humanity's next great adventures in space. China has bold ambitions, including landing astronauts on the moon before 2030, and establishing a permanent robotic research base at the lunar South Pole by 2035. To do that, you need a sustainable way to live and work on the moon for long periods. Carting all your air and rocket fuel from Earth simply isn't practical or affordable for a permanent outpost. You have to use the resources that are already there. The moon's South Pole is believed to hold vast quantities of water ice in permanently shadowed craters. Imagine landing a base there with this artificial photosynthesis technology. You could mine the lunar ice for water, and the system could use that water and the carbon dioxide from astronauts' breath to continuously generate breathable air and rocket fuel. This would dramatically reduce the base's dependence on Earth. It would allow for a permanent human presence on the moon and create a stepping stone for even more ambitious missions, like sending crews to Mars. This is how we go from visiting other worlds to living on them. Making fuel in space is the key to unlocking the solar system. Rockets need a huge amount of propellant to escape Earth's gravity. If you can refuel in orbit or on the moon, you can launch missions with smaller rockets or carry much larger payloads to distant destinations like Mars. A lunar base producing its own fuel could become the gas station for the entire solar system. This is the long-term vision, an interconnected infrastructure that supports exploration and commerce throughout deep space. It's a future where humanity is no longer tethered to its home planet. Ultimately, this successful experiment aboard Tiangong is about more than just a clever piece of chemistry. It's a powerful demonstration of how science can solve the immense challenges of space exploration. By learning to mimic a process that nature perfected over billions of years, we are finding ways to sustain ourselves far from home. It brings us one step closer to a future where humans are a multi-planetary species, exploring the moon, Mars, and the cosmos beyond. The journey to the stars is long, but with innovations like this, we're learning how to pack a little lighter and travel a lot farther. It's a very exciting time for science.